Okay, so this is going to be our first cut on the lathe. We're going to do a very similar thing on the mill. We're going to be checked out for the very first time, where I'm going to approve you to run the machines without supervision, but you're first going to have to demonstrate that you can operate the machine safely. And we're going to have each student do this with their very first project on the lathe. We're going to be doing the Scribe, or the aluminum Scribe. And we've already cut the material, and you've been checked out on the horizontal bandsaw. So I have my material here cut. And on my drawing, I'm going to go to the back side of the drawing. I have a Scribe process sheet that shows the steps we're going to take here. And I'm going to go through step number one. Everyone's going to do this. And I'm going to watch you use the auto feed. We're going to face and turn this diameter and the length, and then you'll be checked out on the lathe. So for step one, the first thing I'm going to do is I'm going to take my stock, my material, also called my stock, and I'm going to chuck on the 3/8 or 5/8 diameter stock with 2-inch material sticking out from the jaw face. And this is actually a little bit longer. So, and my material's already been cut, but I'm just using this as a sample. It's already been turned, so I'm going to use my scale, and I'm going to measure from the jaw face here. And it doesn't have to be, exactly 2 inches, but I don't want it 1 inch 900,000. So a little bit over is fine. I'm going to tighten this, check and make sure it looks good and secure in the chuck. Okay. So after I have my work holding done, I'm going to face the minimum cleanup. Now, there is another basic principle on the lathe, and that says that if I am sticking my material out from the jaw face more than 3 times my diameter, then I need to support the end of the workpiece. And we're going to be doing that on our third operation here. We're going to be center drilling the backside and holding the work with a tailstock to maintain a safe, rigid cut. But in this case, we're kind of right on our limit depending on our diameter size. So I wouldn't want to stick this really any more out than 2 inches in order to face and clean up. And to face and do the second part of step one here is the face minimum cleanup. I need to determine the RPM, so I'm going to measure with my caliper. I'm going to make sure the tips are clean and this is 0, and it repeats to 0. Which it does, it looks pretty good. I'm going to measure this, and this measures, this is really small, this is 450 thousandths. So I'm going to calculate using the RPM formula, and it's going to be 4 times 300 is the cutting speed, because this is aluminum, so I'm using a cutting speed of 300 for aluminum. 4 times 300 is 1200, and then I'm going to multiply, actually I'm going to divide that by 450, which is the diameter of my material. In this case on the lathe, I would be dividing by the diameter of the end mill, or the drill. In this case, I'm dividing by the diameter of my material. And I come up with 2,660 RPM. So for this, I'm going to cut it kind of high. So I'm going to make sure I'm in high gear at this point. And I am going to use auto feed. Everyone's going to use auto feed on this first cut when they turn the diameter. When you're face, you can use the auto feed, and I'll want you to use the auto feed in the very first example that I can see you know how to use it. but sometimes we can, I always teach we want to use the auto feed all the time in facing and turning. But in this case, or in other scenarios, I might just face by hand because it's such a small distance that the tool travels. For the feed rate, I'm going to use a chip load or a feed per revolution in this case, which is basically the same thing as a chip load, a feed per revolution of 5 thousandths per revolution. So every time my spindle rotates, my table is going to feed either along with the carriage travel or the cross slide travel, which is perpendicular to my spindle center line. The carriage travel is parallel to my spindle center line. It's going to move 5 thousandths of an inch per each revolution. So it's going to go, it might seem a little fast, so I'm going to actually lower my RPM. So to start my spindle, I'm going to bring my carriage up here, and I have a little clutch lever here with a red handle. I'm going to bring this out and up. And I always bring the clutch lever up. In an emergency situation, if I need to stop the spindle, I can just hit it firmly and gently with my hands. Most of the machines have a foot brake, and I can step with my foot below, and this will turn the power off to my spindle. I would reset the spindle by disengaging the clutch and re-engaging. I'm set in high gear. This particular machine has a dial for the spindle RPM. I'm going to go up to 1100 RPM. So now that I have my RPM set, I'm going to make sure my feed rate is correct. I'm going to look on the chart here in front of my headstock, and some of these are threads. The bottom one is threads, the top one is feed. Feed in inches, BCM4. So it's BCM4. Sometimes these are changed because they might be set to a thread. BCM4. Yeah, this was set to threading. Okay, so now with my RPM on, I'm going to engage the feed lever. It's the plunge in neutral. Change the plunger. And this looks pretty good. So, disengage. This is what we're going to do for step one. We're going to face minimum cleanup. I'm going to bring this close to the face. I've already checked the tool that I'm cutting on center by using my scale to make sure it's not tilted one way or another with the spindle off. So I know my tool is set to spindle center line. I'm going to bring my carriage feed forward, bring my cross slide forward, and I'm barely going to touch here on the face of the part. Once I can see and hear that it's cut, I'm going to back off my cross slide feed so the tip of the tool is off the part. I'm going to look down to my carriage dial here, determine what each line represents. In this case, one line is 10 thousandths of an inch. So the carriage moves quite a bit further along than the cross slide or the compound rest micrometer dials. On these, most of these dials are 1,000ths per line. On my carriage micrometer dial, it's 10 thousandths per line. So in this case, to get minimum cleanup, I want to cut 20 thousandths off. I'm only going to move 2 lines. And then I'm going to look down and make sure the plunger direction is correct. It's all the way out. So I'm going to disengage my feed with the feed lever. And in this case, I always remove the tool on whatever axis I cut on. So if I'm facing, I wouldn't move my carriage back. When I'm facing, I would move my cross slide back to bring my tool off in that same direction. Okay? You want to get used to doing that. A lot of times you can go either way, but on some of the applications you definitely want to use the same carriage feed or cross slide feed when we're moving the tool. So we want to be consistent in how we practice removing the tool from the material. So that's base minimum cleanup. The second thing we'll do is finish turn. And I'm going to do the same thing, and this is what's going to be required in order for you to be checked out on the machine. I'm going to do the same thing on the diameter. I'm going to bring my tool up to the diameter. I'm going to barely touch the diameter. I'm going to bring the tool back with my carriage towards the tailstock so my cutter is off the part. I'm going to look at my micrometer dial on the cross line, and each line is 1 thousandth. So I'm going to move in 20 thousandths, which is 20 lines here. I'm going to change the plunger on my auto feed down here. Make sure this is engaged in. And I'm going to keep my right hand on my feed lever. So when my tool gets very close to the end of the chuck here, and I'm looking over the top of the tool, I'm going to disengage the cutter. If I didn't quite finish, I can actually bring it in by hand a little bit closer. And then the same thing, I'm going to remove the tool in the same direction, on the opposite direction I'm cutting. So I'm going to rotate my carriage feed this direction. So at this point, you would have been checked out on the lathe, and I'm going to leave you to finish the rest of this part. One of the things I'm going to do is I'm going to, at this point, I'm going to measure my diameter here again. I would write this number down. This is 430, and I would rotate I would hold the handle on my cross slide micrometer dial, and I would rotate this and set my dial to the 0 mark that's marked on the bezel of the cross slide dial. Now, based on the number, I'm actually a little low for the finished diameter, but I'm going to feed in to take off material based on the fact that I know I have a known diameter now, and let's say this is 450 thousandths, and I have my micrometer dial, cross slide dial set to 0. I'm only going to feed forward in this direction, because if I go back on my cross slide dial, there's backlash, and the number reflected in the micrometer dial would be inaccurate. So I'm always only going to feed in this direction from now on. I'm set to 0. If this was 450 thousandths, I would go in, I would turn this on, I would maybe take another cut of, let's say, 20 thousandths or 15 thousandths. I would take another cut, bring the tool back, measure the diameter, and then I would try and rough the material away until I have anywhere from 5 to 10 thousandths material left from the dimension on the drawing in order to take a final cut to get the dimension accurate. And I would be measuring with my caliper or my micrometer, the dial, the diameter each time, making sure that I understand how much the movement corresponds with the diameter here. The one thing about the micrometer dial is, keep in mind, this is a diameter number. So when we cut, we're actually only cutting on one side of the part. So it takes only from this edge of the diameter, it only goes in half the distance, the radius in cutting, but it cuts it off the entire diameter of the part. So this number always represents a diameter number. If I were to take 10 thousandths off this diameter, I would do that by rotating my cross slide in 10 thousandths on the handle in the micrometer dial. Most of the machines, excuse me, most of the machines do have set screws on the micrometer dial, and there's a chance that this dial could actually rotate while the micrometer dial does not rotate, very similar to the mill. The mill, you have to make sure the micrometer dial is tightened against the plate in order for it to rotate when you rotate the handle. There's a few micrometer dials on a couple of the lathes that are like that. Most of them, though, have little called detent pins, and they will rotate accurately and stay in place as you rotate, and you don't need to change the set screw or use a thumb screw to make sure they're tightened down. Okay, so after you've cut the 437 diameter, or you finish turn the 437 diameter, after you would again be roughing and then take a finish pass, we're going to spot, drill, ream the 157 diameter. So the way we do that is I'm going to take this off. I'm going to bring my carriage all the way up and make sure I have clearance here, and maybe bring the cross slide back so it's kind of out of the way. I would bring my tailstock up, and on the tailstock there's two levers. There's the bottom lever here, the larger one. This locks the tailstock in place from moving. If I loosen this, I can move this forward and backwards. So I'm going to lock this. I'm going to bring out my ram, sometimes called the quill, and I'm going to take my Morse taper drill chuck, and it's got a little tang here, and some of these, most of these have to be lined up correctly. So in this case, the tang sits not quite horizontal. Make sure this is clean, make sure it's lined up correctly. Make sure my ram is out at least an inch or more. And I'm going to kind of throw it in there, and that's good enough. I'm going to remove by hand the drill chuck key. I'm going to take my number 3 center drill, and I'm going to tighten by hand, and then I'm going to use my drill chuck and tighten this. And then I'm quite a bit of ways from my material, so I'm going to push my tailstock up a little bit more. Let's see if I can bring the tailstock back a little bit. And I can calculate my RPM, but I know my RPM is good. In this case, we're only spotting for the hole, but I would spot for the drill I'm going to use, which is a 147 drill. I could calculate my RPM, and I know it's over 2,600 RPM, but I'm going to keep it really low. I'm just going to not feed as quickly as I probably would if I had a really high RPM. So I'm just going to go in and touch, just barely using the tip of the center drill. I'm going to bring my tailstock back, bring my ram back as well a little bit. I'm going to take my sometimes you don't want to bring this too far back because there's a little bar in there that will take the tailstock off the taper. So that's a nice little center for my drill. I have these yellow boxes that will be available on the surface plate near my toolbox that you can select, and it has a 157 reamer and a 147 drill. So I'm going to use the drill here, put this by hand in here. And bring this forward with it. Do not bring this forward with the spindle running, just in case this is, you got to get used to the weight of this, and just in case this is running and slams into a running spindle, it could be very dangerous. Now, on the drawing, it shows the drill diameter of 1.147, and to a depth, it has a little symbol that stands for the depth of 1.13. Now, on this tailstock, and most tailstocks, there is a micrometer dial on this as well. And there's a 0 mark. And what I can do is when I run this, I can hold this micrometer dial and watch until my drill starts to drill. And once it starts to drill, I can let go and start drilling and just count on this particular dial. 1 revolution of the dial is 200 thousandths of an inch. So I need to go 5 revolutions plus another 130 thousandths to get 1 inch, 130 thousandths. So I'm going to do the same thing. I'm going to get to my 0 here. Start drilling, I'm going to let go. I'm going to pop a little bit here. That's 200 thousandths. That's 400 thousandths. Slow because this aluminum can melt in there, but I can feel it still cutting. That's 800 thousandths. Okay, now it's getting a little rough, so I'm going to take this out. Turn off my spindle, and I'm going to remove the chips off of this. I think the material is melting within the flutes of this drill. It's a deep hole aluminum. It's a deep aluminum hole, so there's not a lot of room for the chips to escape. So I'm going to start over. Now, I don't need to do my 0 again because I can just determine this is my 0, 200, 400, 600, 800, 1 inch, 130 thousandths. So I was able to do that. I think I was pretty successful in, I only pulled the drill out and removed the chips 1 time. You may have to do that multiple times. This particular machine, this tailstock, I can feel it very well. so I can determine by feel that the chips were getting packed in there. So there's a quick and easy way to check the depth of this, and I'll show you how to do that now. I'm going to remove the drill. I'm going to measure the length of the drill. From the tip of the drill all the way to the end is 3" 110 thousandths. I'm going to turn the drill backwards in the hole. I'm going to put it in there, and I can feel that it bottoms out there. So this feels pretty good. So with that sticking in the bottom of the hole, bottom down on the hole, I'm going to take my caliper and I'm going to measure the distance sticking out. 1" 990 thousandths. So I'm going to calculate 3.11 minus 1.99 equals 1" 120 thousandths. Based on the drawing, that is a 2-place decimal, and it's plus or minus 10 thousandths on that depth. So I'm right at the low tolerance. I'm not going to go back in and make that hole any deeper. Okay? Now, from here, I'm going to do the same thing with the reamer. However, with the reamer, I'm going to, make sure this is pulled out. I'm going to use the same RPM, but I'm not going to peck. And in this case, I'll actually use a little bit of oil here on my tool, just a little bit, from the red can. And I'm going to start with the 0 here and make sure my 0 is good. This is going to be exactly, the depth is 1" on the drawing, so I'm going to go exactly 5 revolutions from this 0 line here. 1, 2, 3, 4, 5. Now I will, when we run this part on our, during that lab time, I'll have a set of pins that are marked with the diameter. One will be a 156, there'll be a 157, and then a 158. So we can use either the 156 or the 157 to determine that we have the correct depth using the same concept. We'll measure the length of the gauge pin, make sure it bottoms out in the hole, and we'll measure the distance sticking out and subtract that from the overall length of the gauge pin, and then we will determine the depth of the reamed hole from there. The 158 pin should not go in this hole. So that is spot drill reaming in the first operation. And then the last operation here is finish turn the 15 degree to a diameter of 210 thousandths. I'm going to remove my reamer. I'm done with my tailstock at this point. I'm going to remove the drill chuck. I'm going to chuck on the chuck key by hand. I'm going to place this back in my tool rack. I'm going to pull my tailstock all the way back out of the way. For the 15 degree, it's pretty easy, but we're going to be using the compound rest feed. to cut this. So what we're going to do is I'm going to rotate my compound rest to where this is from this 0 right here. This is set to 0. It's going to be 15 degrees in this direction. 5, 10, 15. And the way I have ground your tools, I am going to be able to rotate my tool post. So if I make this face of the tool post parallel to the compound rest, this face perpendicular to this side of the compound rest, I'm going to tighten this. And if I put the tool back in here with the angled holder, again, not the straight holder, but the angled holder, this should give me clearance in the front of the tool and in the back of the tool that I'm cutting on, just on the tip of my cutting tool here. And I'm going to make sure my compound rest is not hanging over too far here, so I'm going to move it back a little bit. I'll bring this forward. We're going to use that same RPM. I would calculate it at the lowest diameter, which is 210 thousandths. I'm going to bring this really close. And you can even bring this back a little bit further on the compound rest. But I'm going to just start right here. I'm going to 0 my cross slide, always only going now in this direction. I'm going to 0 my cross slide. And once I have it set up like this, and I'm about to cut, I'm not going to move my carriage dial at all. Because as long as I don't move my carriage dial, it's not going to change where I start my angle in this axis. So I can go off of my cross slide dial to determine the diameter. As long as I don't move the carriage in and out, this number will always reflect exactly how much I'm taking off on the finished diameter, which is 210, where the drilled hole is. So I will start this up. I'm going to try and go in one direction, then I'm going to go back. I'll go back to my cross slide, and I'll just go another 20 thousandths. And I'm going to take another cut. And then maybe another 30 thousandths. I know my hole diameter is 157. I'm getting close. I'll go another 20 thousandths. So I'm not sure if you can see the angle, but at this point, I'm going to take my caliper, and I've zeroed the caliper, and I'm going to do my best to just measure this front diameter, not the back diameter where the angle ends, or where the angle meets the finished turn diameter. But here in the front, I'm going to just go, okay, so this is 320. So I've got 110 thousandths to go. I would continue on. Let's go another 30. And then maybe another 30. Okay, now you should be able to see how close that is now. I've taken 60 thousandths off. I should measure maybe 260 thousandths. That's exactly, I'm right at 260, so I know I'm going to take 50 thousandths more off. I'll go ahead and do another 30. another 10. So at this point I'm really close, so what I would do is I would measure again and start going shorter distances, maybe 10 thousandths at a time. And then the smallest distance I would cut would be 5 thousandths. And then when I've determined this is going to be my last cut, after I measure this, when I take this last cut, I'm going to make sure this is a really nice good finish. And I would measure the diameter here. And that is the final part of cutting the 210 diameter at the 15-degree angle based on that angle. So this will be one of the first things you do. This is the complete operation for that. I'll have another video posted on the next steps on this particular project.